Hi there, and welcome to Al and Merrill.
My name is Merel, and I like to do deep dives into the latest research on neurodiversity.
And I'm Alistair, psychotherapist. I love creating metaphors and stories to help make sense of it all. And together we're going to be exploring the fascinating world of how neurodiversity shapes our lives. So let's dive in. So this episode of Al and Merrill is brought to you by mycopilot.ai for when your willpower won't. So you know those 2 a.m. moments when you're caught doom scrolling and you know that you should really be going to bed? Or the sofa after work where you've collapsed and you're stuck on your phone? Well, My Copilot AI is your personal AI co-pilot that will help you get on with the things that you really want and need to do in those moments, whether that's doing the laundry, getting on with your projects or hobbies, or going to bed. Check it out at mycopilot.ai.
Just a note to say that we're explorers and storytellers. This podcast is not intended as therapy, advice, recommendation, or medical authority. We are just like you, inviting you along on our journey of trying to make a little sense out of fascinating research on neuroscience and neurodiversity as best as we can. Hello.
Hello. So, what's the plan today? What's the gossip? What's the jazz? What are we talking?
I have loads of things, and I am
your message
not sure
sounded.
I'm not sure if we're going to manage to discuss all of it. Maybe not. I don't know.
Great.
We'll see.
Let's
how far we get.
rabbit hole on something interesting in it.
I have a few kind of different topics. First of all, I thought about discussing oral health very briefly because I couldn't find much on that, but it just came up last time.
No, I didn't
what
find
was
anything
the
on
thing?
that either. I don't think anyone's researched it. So it's not like it's like, no, that's not a thing. It's like, I don't think anyone's even ever asked.
There have been a few studies, but I don't think anyone has asked the question of, like, last time we talked about the blood-brain barriers and like about antibodies entering the brain and that kind of stuff. And I don't think there have been studies that look whether oral health can cause antibodies to get into the head and brain and stuff and cause ADHD symptoms. But there have been a lot of studies looking at the relationship between mainly ADHD and oral health, but those have been mainly on the topic of, like, do ADHD symptoms cause bad oral health? Like, they're kind of focused on how symptoms of ADHD, such as sensory sensitivities or executive dysfunction or communication difficulties, how they cause people to care worse for their oral health and kind of cause worse oral health. I found one study though on autism, which is much less studied in combination with oral health, which actually finds lower pH of saliva, which is bad, which is bad for your teeth generally.
Interesting.
But apparently people with autism had significantly lower pH.
So more acidic mouths.
Yeah, more acidic mouths. Also
We
reduced.
are aliens. We spit on you when you annoy us and it melts through your face. This is actually the original evolutionary survival strategy of autistic people. We were a spitting defense mechanism. But then, obviously, with the last ice age, that just kind of came out.
Then there was also reduced calcium in saliva, which I suppose is bad for the teeth because the teeth need calcium and it was less present in the mouth.
Talking last time about calcium being something that people
that was related to vitamin D3
anyway. Yeah. Okay. So again, that calcium story. So I mean, that's how we got onto teeth, wasn't it? Yes. Okay. Carry on.
That does make a lot of sense. Yeah. If autistic people have reduced vitamin D3, they might also have reduced calcium, and they probably have worse mouth calcium teeth situation.
I wonder if that's associated with acidity.
Maybe. Don't know the pH of calcium. Anyway, but so there's these two things that are worse for oral health: the lower pH and less calcium. But there was also increased saliva proteolytic activity, which means a high pronunciation. Anyway, basically means higher level of enzymes in the saliva that break down proteins, protecting against caries.
Oh, that's interesting. So actually,
there is
naturally
less
extra
saliva.
Defense.
Yeah, exactly. There's less saliva, there's worse teeth, but there's more activity to break down the proteins that can damage the teeth.
Okay. So I have a random association here, which is, So basically dry mouth. Less saliva is like dry mouth. Like I'm always dry mouth, right? I always thought this was because I was ever so slightly pre-diabetic because I'm ADHD, so I snack on too much sugar, right? Which then has consequences on endocrine systems and what's the one I'm looking for? The pancreas? Whatever does the insulin. It's the pancreas. No. Oh wow. I feel like I should know this stuff. This is what happens when you only have 4 hours sleep. You just brain goes foggy. I'm seeing connections, but I'm not really pulling them through. I mean, that's what we're talking about, isn't it? It's the like the ion load. It's different. The thing that I was just thinking there was dry eyes. I get really bad dry eyes. So there was a part of me that was like, I wonder if my face is dry. You know, mouth is dry, eyes are dry, sinus is dry. Like maybe they're actually all related. Maybe the driver. And maybe because of that, the mouth overproduces enzymes or compensates by overproducing this proteolytic stuff. Theory. I'm completely speculating. As ever, I have questions. It seems a little bit, it seems a rabbit hole there, doesn't it? It's like, it's sort of I would put this in the bucket of yet another cluster of related symptoms. That was like a little side quest. Okay, what else have we found?
Last time we were talking about the autoantibodies, right? So that autoantibodies are found in people with autism or ADHD in areas like the prefrontal cortex, the cerebellum, the hypothalamus.
All the wrong places.
Yeah, the places that we know are impacted in autism and ADHD, that autoantibodies have been found in those areas, basically attacking the brain.
And
of
let's
these
just
people.
remind our listeners and me what an autoantibody is.
Right. An antibody is a cell in the body attacking intruders. There can be an antigen. An antigen is something that is intruding the body that is not recognized by the body. Then the body creates T and B lymphocytes, which are...
Let's do just like a little brief headline, which is like basically antibody. I find antibody as a name hilarious because the body creates them to kill things that are not the body. There should be antibodies.
They are bodies themselves. So now you're restricted to the body of the human body, but it's a cell body.
True. So
It's
they're
a
bodies,
tiny
they're little
body.
cell bodies that are anti everything other than their host body. In theory, but what actually happens, as we discussed in a previous episode, was those little buggers can run amok and the guardrails can fail and they can get overexcited and overgenerous in their warlike activities and death and destruction seeking. So they go and kill stuff that they shouldn't. And they generally shouldn't be allowed to run around in everywhere because they tend to be rather destructive. So there are various barriers, right, where it's supposed to stop them.
They're supposed to attack intruders, which are not from the body itself, but then they do sometimes attack tissues that are actually from the human body itself. Some of the autoantibodies were targeting Golgi neurons in the cerebellum. Golgi neurons are a type of GABA interneurons. So GABA stands for gamma aminobutyric acid. I'm just going to say GABA from now on. Reason why I mentioned that is that I then remember that a few months ago I had read another article about GABA. So this article has two main findings, basically. One finding is that people with autism generally have less GABA neurons floating around. In people with autism, there is a positive relationship between the amount of GABA and sensory hypersensitivity.
Amount of GABA. So GABA's a thing, is it, that floats around? My understanding, I can't remember the details. The vibe that I remember from GABA is that it's like a bit like glue and like a fundamental sort of substrate of the brain that like makes it work. Like it's about managing the brain itself. So when GABA stuff changes the way the brain functions, like within itself changes.
It's doing many things. It's both involved in early development and in adulthood as well, but it has different functions. So in early development, it regulates neurogenesis. So it basically regulates the generation of the neurons in the brain. So it helps building the brain. In adulthood, it serves as a primary inhibitory neurotransmitter, where like inhibition in terms of neurotransmitters means the process where neurotransmitters reduce the activity of other neurons. So they kind of regulate or dampen the signals of the other neurons in the brain. So if there is less GABA, that basically means that other neurons can go out, right? They GABA is required for dampening other neurotransmitters to do their thing.
Sounds a little bit like the parents of kids. Like when a child is like learning, the parent wants to be encouraging. And when they get a bit older and start going wild, the parent needs to be like, whoa, 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 there are edges to behavior that is like not dangerous or socially unacceptable. And what you're describing is like when there are not enough parents around, the children turn into, some Lord of the Flies craziness inside our brains.
Which is why people with autism have been found to have lower GABA levels of GABA, leading to kind of hyperreactivity in the brain and heightened behavioral sensitivity. So there's a lot going on in the brain which isn't tuned down by these GABA.
So in some sense, our neurons just take everything too damn personally. And if there was some good old GABA kicking around going, look, don't overreact already. Like it's not that bad. It's not the end of the world. Like, yes, it's a loud sound, but like, it's okay. We can manage this, right? Parent reassuring the child. But without that parent mode, child just goes, oh my God, loud noise, scary, and overreacts like mad, and then shouts and screams, which is a bunch of neural noise that then does the same thing to the next connected neurons and basically passes the overwhelm on. So we have childish brains, like internally.
With less parents than...
Childish neurons. And obviously this is only an analogy to kind of give a story around it, like a little metaphor. I guess, maybe another example would be something like business. Like if you let business people who want to make money do whatever the hell they please, you will get some really dodgy businesses being built, doing really crap things. You do need some regulatory oversight to say, look, there are rules, like, some consumer protections and that sort of stuff. And if you don't have that, then your society turns into a little bit of a wild west. You'll just end up with essentially warlords, rich warlords. So a bit of regulatory oversight stops everything falling apart. Okay, yeah, that's sort of slightly sad. Like that makes me feel like not like mad good, because I guess then we have to make more effort as an individual ourselves to try and stay regulated. And this is the word that I keep banging on about with like neurodiversity. It's all about regulation and the struggle of regulation. So I think neurotypical people sort of just are more regulated. Like intrinsically, they have to spend less effort regulating themselves. They're able to do things like the laundry and tidying the house and dealing with loud pubs with far less effort, because I think we have to make that effort from something other than our intrinsic, because it's not happening. Basically, we have to send the UN in, but that requires a lot of resources to try and stop the conflicts running amok, and it's just tiring, right?
Yeah, so I thought this was quite a good example of last time we spoke about all these antibodies in the brain and how they're kind of targeting the brain. But I thought this was a quite specific example of how these autoantibodies can target a specific neurotransmitter to cause a very specific effect that is clearly related to neurodiversity, like the tactile hypersensitivity. One thing that was strange about, or like another finding of this specific article, was that like the first thing was that people with autism had lower GABA levels. Another thing was that so GABA levels are varying amongst all people, and in people with autism, the level of GABA is related to the level of sensitivity, and in neurotypical people, it is not. It has no correlation whatsoever to the amount of GABA that's found in their brain.
That's interesting.
And I don't think they gave an explanation for this.
So my first instinct on that was to wonder about like the reuptake process. Like, for example, you feel de-stressed when your body soaks up the cortisol it has created. So it creates cortisol so that you can soak up the cortisol, and by soaking up the cortisol, you de-stress. So cortisol is highly correlated with stress, and you stay stressed if you can't soak up your cortisol, and you stay stressed if you can't produce cortisol so that it can be soaked up. And I'm wondering whether it's a similar thing here, where if your system is working well, then the GABA being produced and the GABA being uptaked is in balance. And that process of soaking up GABA, creating and soaking it up. So it's not like just the GABA existing that does anything. It's the GABA is just like a moment in the workflow, a process. that is like creating stuff and taking it up, creating stuff and taking it up. And it might not be just GABA, it might be some other stuff as well. But there's a process, and somehow the process of taking up GABA, creating and taking up, allows the regulation. So I'm wondering whether the fact that there's more GABA and therefore more sensitivity is a sign that whatever is soaking it up isn't doing the job. So it's not that the GABA is like the thing itself. It's the next part of the process that might be the bit where the sort of the magic happens, where we go, that's how we regulate. So the more GABA's still kicking around, maybe the more that's not working in balance. But that's a theory. That's just that's the sort of mechanism that brains often do, like that sort of like multi-step process, which kind of boggles the mind a little bit, because we want to be like, yeah, but the thing is the thing. It's like, it's not really. It's the changes in things that we call things that have a like experiential impact. And it's not the thing itself, it's how it flows and changes. So you have to look at dynamics and patterns to get the phenomenon that we put a label on. So if we just look for a thing that represents like happiness, serotonin, it's like, it's not that simple. So was there any, I think the last thing I heard you say was that that there wasn't any, they weren't like saying why or explaining that or breaking it down. So it's just like, guys, look, the thing. And we're like, yay, cool. All right. Okay, so lots of space for storytelling and no constraints. I can invent whatever story I want for this then. It's nicer when there's some guardrails. I guess I'd like to find out a little bit more about like the GABA process and what that does. Like we've spoken about it being like a kind of like, I don't know, like almost like a scaffolding or maybe like plumbing and electricity in the house, right? The electricity wires stuff up, or like the Ethernet wires up, but it doesn't do much by itself. It's just connecting stuff.
I will look into it more, because I did read more stuff about like the blood-brain barrier and autoimmunity and inflammation and that kind of stuff. And I did see the GABA returning a few times, like not elaborating on it, but it seems to return in some articles as well. So it's, yeah.
Actually, can I just ask one? Yeah, you were talking about interneurons, and we were talking about the cerebellum. And obviously, I have a love affair with the cerebellum. Are interneurons a neocortical thing, a cerebellar thing, or a just everywhere thing? Because the structure, of course, in the cerebellum is much denser and more highly connected than in the neocortex. So I'm imagining like the fundamental architecture is different, which means
in terms of GABA, it is mentioned that it serves as a neurotransmitter in the cortical and white matter interneurons, which at least suggests that it's in many parts of the brain. I'm not sure.
White matter is neocortex, I think. Oh no, hold on. White matter is the grey matter is the. And you see, this is stuff that when I'm. So I apologize to our listeners because I've had bugger all sleep, but when my brain's normally on it, like this is the stuff that I'm.
White matter is the tissue through which messages pass between different areas of grey matter with a central nervous system.
So if you imagine a picture of the brain, you have the stuff going on in the middle, and then the sort of nobbin in the middle, the thalamus. It's all the old stuff. We sometimes call it reptilian, and that's surrounded by all the limbic system and all the basal ganglia stuff that we were talking about. It's part of that, and that's like a wraparound of the thalamus. So it's a bunch of like really hyper specialized little nobbins. They all do different things, but there's like this loop that goes around the middle that has all these things in like a row, like almost like a roller coaster of electrical excitation. And then you have the neocortex, which actually sits kind of like further out from all that stuff and has like these columns of processing units with like loads and loads of cells in them, loads of neurons in them in certain structures. And each column connects to the columns next to it. And that's what your neocortex is. It's like this carpet of these columns of neurons that are structured like almost like mini processing units. But they float like quite far away from the limbic system and the thalamus and stuff. And there's like basically a bunch of like, if you were to draw it, you just draw the lines going out to it, and you see that when you draw a picture of the brain, you sort of the folds at the top is the grey matter, and then there's all these lines connecting to the middle. I think we're talking about those lines. So that would not be cerebellar. That's then specifically about how to make like basically the information passing from the neocortical sort of columnar processing units to the limbic system and the thalamus and all the kind of like old school stuff. That's my fuzzy day articulation effort, I think. So I'd be surprised to see those in the cerebellum, because it's like a whole different thing. I mean, I think you'll have GABA sensitive cells there, or GABA, but they probably have a different structure, do a different job, or maybe the same job, but in a different way. So I think what I'm taking from this a little bit is like maybe some kind of like road metaphor, like if you had let's say you got like farms and restaurants, right? So let's say a farm is like a sensory neuron and a restaurant is like the motor neuron. So like, something, you sense something and maybe there's a reflex action that follows it. Obviously a rampant simplification, right? But let's say it's that sort of idea. There's a production and a consumption. There's one world and then there's another. How do you get your carrots from the farm to the restaurant? On a road. Is the road associated with carrots? No. Does the road limit itself to farms? No. You could have warehouses and shops. You could have homes and offices. Like there's loads of stuff that could go down a road, but you need the road to shuttle stuff around. In this case, the things that we're shuttling around is, electrical excitation. I think it sort of doesn't matter whether the road is like an industrial road or a town road, right? So the cerebellum, I mean, they're probably going to look different, right? So a street in a residential area looks different from a road in a warehouse district. Still roads.
Can you pick the GABAs in this story?
Well, they seem to use the GABA, like soak it up to do their job. So
isn't the GABA?
So they're like, I mean, the road analogy is a bit daft actually, because what they're mostly doing is inhibiting, right? They're stopping things from overdoing it. So they're actually trying to slow the cars down and stop them going over. They're like, look, don't go over the crazy like stay on this path to make sure that not, that the because we're talking about electricity, right? Like fundamentally, that's what's happening, right? There's electricity flowing everywhere, and electricity is bloody fast and wants to go everywhere. So it needs to be controlled, and so it's maybe a bit like pipes, right? If you're trying to get plumbing to go somewhere, right? You actually want to put gas or water or whatever it is down pipes. You don't just want to go here, just flood. The way that we get water to our citizens is we just flood them. That's like not a clever strategy for delivering hygienic water to people and stuff. I think the interneurons are basically like the piping that's responsible for making sure that stuff goes the right way, and then chilling it out and going like, don't go too fast. Traffic lights to say, if you will just drive as fast as you can, you're just going to pile into each other. Like there needs to be some traffic rules, and they use GABA to do that. They soak it up and use it to do that. So if they're not doing their jobs properly, you probably get a load of GABA floating around that isn't being consumed. GABA's like the light that you could use for a traffic light signal. But if the traffic signals don't work, then you've got all these, the lights kicking around not being lit up. That's such a terrible analogy. But like if you imagine like I don't know, batteries that if you put the battery in the traffic light, it powers it for a bit, right? The GABA's like the battery that turns up that you plug into the traffic light and it powers the traffic light. Take the battery away, traffic light don't work. Or if the traffic light is broken, you can put a battery in it and it'll just be like, still nothing happening because the light's broken for some reason. So someone's going around doing all these, like going, right, who needs a battery? Who needs a battery? I've got some battery, GABA. And traffic lights are there going, all right, chaps, yes, that bit of sensory information is highly relevant. We will pass that on and chill out and do it in nice little sequenced blocks of activity rather than just complete chaos. Because obviously the brain hasn't invented roundabouts yet. But this then, because it's roads, it applies everywhere. So it doesn't matter whether what you're doing is the consequence of some neocortical information churning, processing, that needs to be sent back to the cortical stem and stuff. Like it needs to be sent back somehow. So it needs to be managed in its sending back. But that's going to be just as true. Like the bit that I've just got in front of me here is like looking at the hippocampus and stuff, which is very much down in the sort of center there. The brainstem and stuff, which is very much not the neocortex. So I suspect that what I'm looking at is that they're like a type, like because when we think of neurons, normally we think of like a classic They're called pyramidal cells, aren't they? They have a particular shape. Like there's multiple different types of neurons, and some of the ones that do like certain types of processing have like different shapes. I think interneurons might just be like bog standard neurons that. Okay. I love how incredibly competent and informed we sound. Like we're really on top of our stuff here. Like we're experts. Like anyone listening to this is like, no. We're working it out alongside. We're trying to find the stuff. But like neuroscience has vast amounts of complexity to it, and there's lots of details, and there's lots of funny words that are hard to remember. And even if you go and study the damn thing, pointing at self, if you don't do anything with that information for 15 years, it's like, I know this stuff. Hold on. How does this hang together? Like 15 years ago, I could have drawn you diagrams and been like, yes, this and this and this, and pointed at everything. But I don't know, the real world. Like how many times in ordinary day-to-day life when you're, say, talking to an ADHDer and helping them get through their rejection sensitivity dysphoria because they're feeling really shit about something, how many times do you genuinely say to them, listen, I know it's really tough, but you're into neurons, right? You just need to do some interneural gardening, right? Because your pyramidal cells are a little bit strong right now, you know what I'm saying? It's like, yeah, just tap those pyramids down. And they're like, completely meaningless, right? You don't talk about this stuff as a lived experience. I still want to know how they fit into the cerebellum though, because it does say that they fit in, but this is the thing that I'm conscious of, is that we have spent the last 50 years being extremely interested in the sort of like the triune brain, like the neocortex, thalamus, limbic system, like loads of, like a lot of what I actually was really interested in and was studying was memory, like the hippocampus and everything that led into that. And that was kind of the bit that I was most geeky about, and how we did even basic things like spatial mapping. Your brain has like weird map representations internally. You can really niche on any of these things, and it's a complete rabbit hole each one, and quite new. Like, it's our generation, it's our lifetime that a lot of this information has come out. So we really don't know a lot about the brain, even though we know more and more and more. And I think certainly what I'm picking up is that a lot of people have only started looking at the cerebellum as something like more than just motor, just a motor effectiveness, like as in tell the body to move smoothly rather than darkling, being like, I can't move my body. That can fail. And then people do that. I think it's in my observation, it's only like the last 10 years or so that people have started looking at the cerebellum going, maybe there's more to this little puppy than we thought. So I think some of these curiosities might be harder to find. They're side notes in other research, like, the interneurons. Oh, yes, they're also in the cerebellum. Like, it was, they're just less front and center. So, yeah, that's a bit of a waffle about all of this. That's me kind of just being like, God, brains. I love them, but damn, there's a lot of stuff, and it's detailed. Anyway, that's my story for GABA for today, I think.
Cool. Also don't have more on that. So, shall we move on to mast cells?
Another one. Goodness gracious, you really have got a whole...
I do. I still have another one after this.
Okay, charging onwards.
Do you know about mast cells?
I remember that I remembered them.
I came to the mast cells for the reason of researching the blood-brain barrier permeability. Yeah, I was researching that and then found an article, or 2 articles actually, on mast cells, which are linked to these gastrointestinal issues, migraines, and also the destruction of the blood-brain barrier. Or not destruction, just involved in the process.
Okay.
So
They
mast cells
seem relevant.
are basically, one of the articles says they are considered as the immune gate to the brain. So they are usually kind of placed around the blood-brain barrier and to kind of function, as
Is it?
they have function of...
I never knew that.
So they have essential roles in allergic reaction, in immunity, in inflammation, and they have various functions, including vasodilatory.
It does increasing your the size of your capillaries so that more blood goes rushing around your body.
Yeah. Pro-inflammatory molecules. They can release pro-inflammatory molecules. The brain, especially the hypothalamus, contains many mast cells located around the blood-brain barrier, and also a lot of words today that I can't pronounce, corticotropin-releasing hormone, or CRH, which is secreted under stress. So if a person is stressed, they release this CRH, and this activates the mast cells and is then responsible for mast cell-dependent blood-brain barrier disruption. Basically, the correlation between ADHD and autism, the relation between that and stress levels is present.
So am I hearing correctly that so if you're being flooded by CHR, I don't know whether that's the same as cortisol or part of the cortisol system, that messes with mast cells. And mast cells,
it activates mast cells, it says.
Okay, so it makes them do what they do more.
I think it makes them release certain things or make them let go through certain things. I'm not entirely sure.
What I'm seeing about mast cells here is that they're part of the basic immune system and allergic responses. So if releasing the stress hormones or the stress chemistry basically makes this stuff overactive, then that messes with the blood-brain barrier.
Then this barrier lets more things through.
So it becomes more permeable. Okay, so there's what jumps out to me here is this the relationship between trauma and neurodiversity, right? Because trauma is basically, put another way, your body being in a constant stress state because you think that bad things are still happening even after they're not, right? So a trauma is like an open wound. It just stays open and your whole system goes, oh no, we're in a bad environment. Stress, 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 even if that's subjectively not the case. And that's kind of the definition of trauma, right? Or it's a definition of trauma. Which would imply that if you're in trauma ongoing, then that releases cortisol ongoing, obviously assuming also it's not being taken up properly. So my cortisol's all back to front. And that's like, the NHS has confirmed it and stuff. My body basically doesn't do cortisol in the normal way. It's like, full of cortisol. Yeah, fine. Not a problem. I'll make cortisol at the end of the day. That's just normal. Who needs to sleep? And like I was saying, the reason I haven't slept, and we talked about this before we started recording, was because I'm sitting with some stuff it feels very stressful. And that means I can't sleep because my body's just going, I'll make cortisol, loads of cortisol, because that's normal. My body doesn't know that that's like a bad idea. But that then sounds like it triggers the mast cells, which then makes my my protective barriers more permeable, which in the last sort of 2-3 episodes, we've been basically going, hey, that might be a sort of strong correlation story around neurodiversity. And I sure as hell tick neurodiversity boxes. And then there's the intergenerational stuff. Like, does autism follow in families because either
everyone is super stressed?
Yeah. And maybe that family just passes on the stress, either genetically, like a predisposition to being more stressed by the same events, or epigenetically, as in, stressed parents don't exactly raise unstressed children. And that's what it has to be. It just, you have to only be stressed for that, like 1 month, age 2, and you pass it on. That whole argument that people have, it's like, is ADHD trauma or genes? It's like, is that even a relevant question when this stuff is just so intrinsically linked? But I jumped on that really fast from your description. I think you got like 3 sentences in and I just went, whoa, to town on it. So I'm going to give you the talking stick back and go.
You actually related it directly to early life stress, like stress as a baby or as an infant. And indeed, there were also other articles that I found that do relate specifically early life stress, so stress as an infant, to inflammation in general, actually. So that relates early life stress to inflammation, to influence reward-related neural circuits as well. So apparently dopamine regulation, the sensitivity to negative stimuli in basically the rest of the life.
Everything we've been talking about for the last 2-3 weeks, like we've been circling around this inflammation, immune system, barriers of antigens triggering immune system, and this research sounds like it's doing the same thing. It's listing those same, those same actors, different angle. Like they're looking at it from a different thing, so they're writing about it with slightly different English words. But I'm seeing the same cluster of, it's the same play, right? with different languages, but it's the same Shakespearean themes.
That's a good point. And maybe that's a nice way of going to the last two articles, because they go more into the direction of like, what can we do with it? Because as you are saying, in the last hours that we've talked, we've basically discussed all kinds of ways that inflammation and autoimmunity and the attacking of the body of itself is destroying the brains of neurotypicals and impacting it. But what can we do about it, basically? And then there's two major areas that people can actually work with it, which is, one is the gut microbiome, as we also already discussed last time for a little bit. And
Stop
second one
taking in the
is
things that could cross the barrier. Like, if your barrier is screwed, stop throwing bad stuff at it. It's kind of how I hear that.
basically, yep.
Like, yeah,
One is the microbiome, other one is exercise.
because exercise creates cortisol. So how does that work?
Yes.
Because I noticed that I have, and I find this so irritating, I have post-exercise or exercise-induced fatigue, which is a neurodiverse symptoms for some of us. So if I go and do exercise and I make a bit too much of an effort, and the question about where that definition of a bit too much is changes a bit on day to day, I will break myself. Like, I will be completely wiped out for the rest of the day. So if I go to the gym at mid-morning or late morning, and if I make a little bit too much effort, I will feel good, sort of, but I will then be unable to physically function until something like 6, 7, 8 p.m. It wipes me out for, like 6 hours. And that's really irritating because I put on quite a lot of weight and I find it hard to take the weight off, because if I go and do that, I can't get on with my life. So there's something about exercise here where I have a difficult relationship with the word exercise, especially when people say, "Oh, exercise is really good for you if you've got neurodiversity." I'm like, yeah, I don't want to say like, is it? Because it is, but it's complex. So yeah, what did you find around it? I mean, I have a bit of a knee-jerk reaction there, so that's my knee-jerk reaction.
Well, they look into the relationship between the blood-brain barrier and physical exercise. One thing they say is long-term physical activity influences the blood-brain barrier and the central nervous system by reducing peripheral inflammation, lowering central nervous system immune cell infiltration risk, and strengthening tight junctions in the blood-brain barrier. So basically, the blood-brain barrier is made up of tight junctions. That's basically the defense mechanism there. And physical exercise is literally strengthening that barrier. It boosts antioxidative capacity, lowers oxidative stress, has anti-inflammatory effects. Makes sense.
It just says it. It's like, it does this thing. Why? How?
One thing it says is physical activity can reduce inflammation by decreasing the release of inflammatory cytokines, known as myokines, from skeletal muscles. It seems like generally skeletal muscles are releasing certain amounts. I think this is the stress that muscles grow from.
They actually get damaged when you do exercise.
And it seems like they have a certain kind of baseline output of inflammation, like stress output. And that physical exercise can actually decrease the amount of inflammatory cytokines that are released from those muscles.
This is, yeah. So
Over the
this
long
ties
term?
in with like the asthma theory. Have you heard of this one? Basically, the idea is that our immune systems are designed to work with a baseline parasite load. So our immune systems have evolved to be quite powerful. But of course, we live in a time where we have very few parasites, right? We don't have, like, we don't all walk around with like loads of worms and lice and all that stuff. Like, our water is not full of pathogens, right? So our immune system is like a race car that's been driven quite slowly, and a race car that's designed to be driven very fast actually requires like the wind to cool the engine, but we're not driving them fast enough, which means the wind isn't strong enough to cool the engine, which means that our engines are overheating, and our engines in this case are the immune system, which means they're overreacting and they're basically burning other stuff and running amok. Exercise, if our bodies are designed to also move more and like be under constant physical load, right? Because we're always moving and running and walking and doing things, then a sedentary lifestyle, we can easily hypothesize that there are probably many different systems in the body that are expecting to be used more. And when they're not being used more, they're also doing their equivalent of overheating. Like it's a different thing. And maybe the cytokine thing or cytokine thing is like, well, that's what muscles do when they're overheating, right? And they need to be used more because they produce this because they've been tuned to produce it by evolutionary history, and we just happen to be lazy buggers, which means that we're not using them well enough, which means, well, we've now got to deal with the fallout, which is cytokines. And if we exercise, we're bringing ourselves back to our baseline and going, that's what our bodies expect. Like, we need to run the damn thing. Otherwise, we will flood ourselves with.
This article emphasizes that this is very much about long-term exercising regularly, exercising. I don't know if they talk about, they don't say specifically like every day or every week, but like regular exercise, whereas brief, super intense exercise may actually increase the blood-brain barrier permeability and induce inflammation. So if you don't...
So I've been having a chat with a friend of mine who's been like, he's also a bit spectrum, has been obsessing lately about getting fit. So he's been doing like deep research on it and what, how to do it. And his basic take home is walking. Everything else sucks. Like, walking is where it's at, with occasional moments of brief, intense activity that you kind of have to do occasional moments of brief, intense. But actually, almost all the wins and gains are best served by walking, because walking has the least number of side effects and it actually does the job. And it does the job fastest without overextending your energy. And that really hangs here because, like, human beings in evolutionary history won't have been running around and jumping trees and stuff. They would have been doing their best to not do too much at all, right? Because you're trying to save energy. And actually, if you want to get from here to the watering hole, you're not going to run there. You're going to just walk. So we would have probably just walked around a lot, and that's actually what our baseline is, walking around. And actually, only occasionally doing a bit of intense activity when you really need to run away from a tiger or not. But you don't actually want to probably spend every day running around and like getting fit and hardcore. Like, an evolutionary human being would look at you and go, God, that's a waste of energy. What the hell are you doing? I'm going to sit on my ass. Like, I don't have to do anything right now. I'm going to just walk around. That kind of makes sense. Like, it's not exercise. I think exercise, often we think gym, right? We think, I've got to go and really sweat my ass off on a treadmill or like lift some hardcore weights. But actually, the thing that I'm hearing in both what you're saying there and what my friend Joe is saying is that it's not exercise in that concept. It's movement. You just got to keep moving. It's not about making over intense efforts. Just move, and then occasionally make an intense effort to get your occasional wins out of that. They do say the people who live longest are the ones who like just walk half an hour a day or just walk to the shops every day, and it's like they just walk.
I find it difficult to find kind of what is the amount, what is the balance a person should have between long-term walking, because there is an importance to also muscle strength training
there is.
To some extent.
This is exactly what Joe's been completely geeking out on. There is actually quite a lot of knowledge about this and a lot of research on it. So, and this seems to matter to neurodiverse people in particular, because it sounds like we're the ones who are slightly more affected by these systems being out of whack.
Mm-hmm.
So we more, as well as making sure we don't put crap into our bodies, we have a higher consequence if we don't do our baseline.
And we
movement.
can profit more if you do it good, I think.
So the benefits
I think it goes both sides. We can profit more if we do it right, and we have worse consequences if we don't do good.
So annoying. Because it just sounds like effort, doesn't it? It's like, like, I want to solve all this with my mind. I don't want to have to make that effort.
But if you will make the effort, your mind will be better.
Actually, I was going to the gym and I was really enjoying it until I had my accident and busted myself up. I'm quite looking forward to going back quite soon. I'm probably ready to go back, actually. So vitamin D, eat well, and exercise. It's so irritating because it's what everyone's been telling us all the time. It's like, yes, but why? Let's understand all this. It's like, oh, no, it's the same old stuff. Like everyone knew already. Like, damn it. There is no magic silver bullet. There's just the annoying stuff that everyone who's like smug going like, oh yeah, you should totally eat healthy like me. It's so much better for you. We're going to find out that veganism is really good for being ADHD at some point as well, aren't we? It's going to be depressing. Also, I think trying to persuade ADHDers to give up cheese is a losing battle. Cheese is like basically dopamine precursors in block format. Like it's the most fast food that you can get, really. Cool. So what's on the topic for next time, given that we just managed to chew off a huge amount of stuff?
The dry mouth face eyes. GABA is the cerebellum and the Purkinje cells.
Yeah, I'd be more interested in that. Well, let's give it a go. Let's find out. I'll see you next time. Thanks for listening to our podcast today. If you like what we're talking about and want to hear more, do like, follow, and subscribe. It makes a really big difference. You can also find us on social media and our Patreon, Al and Meryl, or our website, alanmerrill.com. Thanks for listening. Catch you next time.